You ever just stop and think, like really think about just how strange it is that we have these minds? Like here we are talking, having this conversation, making plans, and it all feels so normal. And yet,
Yeah, it really is remarkable when you stop and think about it. I mean, we kind of take our everyday consciousness for granted, but it's this incredibly complex process, and we're only just beginning to scratch the surface of how it all works.
exactly. And it makes you wonder what else is out there.
Right.
What about all those other states of consciousness that people have reported throughout history and across cultures? Experiences that just completely blow apart our normal, everyday way of seeing things.
That's right. The kinds of experiences you might have with psychedelics or deep meditative states, even those moments of sudden insight or clarity that seem to come out of nowhere, those are all pointing towards this much broader spectrum of consciousness that we're only just starting to explore scientifically.
And that's what we're diving into today, some seriously mind-bending stuff. We've got excerpts from this research paper by Khalid M. Sak. It's called Simulation of Non-Ordinary Consciousness. And it's not your typical neuroscience paper. It's taking this really wild approach using AI to understand these altered states.
And you hit the nail on the head there with while I mean, Sacco isn't just trying to build an AI that like hallucinates or something, right? He's going deeper. He's looking at how these non-ordinary states change the very structure of how we think, how we use symbols and create meaning.
So instead of mimicking the surface level stuff, the sensory distortions or emotional shifts, he's trying to capture something more fundamental, something about the underlying architecture of consciousness itself.
Exactly. And to do that, he's created this system called Glyph. And it's designed to simulate the kind of symbolic cognition that's been observed in people under the influence of psilocybin. But it's not about recreating the experience. It's about understanding the underlying computational principles.
So we're not talking about building an AI that trips out. We're talking about using AI to help us decipher the language of consciousness itself and potentially even unlock new ways of thinking and creating.
It's a fascinating premise, and it really challenges some of the assumptions that have dominated fields like cognitive science and AI for so long.
Because for a long time, those fields have been hyper-focused on the rational right, on building systems that can reason logically, process information efficiently, make optimal decisions.
Absolutely. The emphasis has been on creating machines that excel at tasks that we humans often struggle with, like crunching huge data sets or playing chess at a superhuman level.
And while that's led to some amazing breakthroughs, it's also maybe blinded us to other crucial aspects of human intelligence.
Right, like the ability to think outside the box, to connect seemingly disparate ideas to come up with truly novel solutions. Those are the things that still set us apart, and they seem to be deeply linked to these non-ordinary states of consciousness.
Yeah, these states that we tend to either dismiss as weird or relegate to the realm of spirituality, but there's a growing body of evidence that they actually offer some pretty unique cognitive advantages.
Like enhanced cognitive flexibility,
Yeah.
the ability to see patterns that we normally miss, and a kind of rewiring of our symbolic understanding of the world.
And the crazy thing is that those are also the very areas where our current AI systems fall short.
Exactly. They can process information with incredible speed and accuracy, but they often lack that intuitive leap, that creative spark that allows us to make those truly groundbreaking connections.
Which makes you wonder if maybe we've been approaching AI all wrong, if by focusing so much on rational thought, we've actually missed a crucial piece of the puzzle.
It's a provocative thought, and it brings us back to Glyph, because this system is specifically designed to explore that other side of cognition, that symbolic, recursive side that seems to be so amplified in these non-ordinary states.
And to be super clear, this isn't about trying to replicate the subjective experience of a psychedelic trip, right?
Right, it's not about making AI see things that aren't there or feel certain emotions.
The focus is much narrower. It's about isolating and simulating that specific style of symbolic thinking that seems to be a hallmark of psilocybin-induced cognition.
And how does Glyph do that? The paper mentions this recursively encoded symbolic loop. It sounds pretty complex.
Well, it's based on this idea that when you're in these altered states, your mind starts to loop back on itself. Right, but it's not just repetition. It's like each loop through adds another layer of meaning. It's all very metaphorical and associative, and the usual boundaries between concepts start to break down.
Kind of like that feeling of semantic hyperpriming that's often described in psychedelic research.
Exactly. The idea that words and concepts become more loosely connected. So you
Yeah.
start to see all these unexpected relationships and metaphorical links.
And Glyph is designed to mimic that process computationally by manipulating language in a way that reflects those shifts in meaning.
And the way the paper describes it is really interesting. They don't talk about Glyph as a tool that you use. They talk about it as an experience that you enter.
That's a very different way of thinking about AI, isn't it? It's not just about input and output. It's about creating a kind of symbolic environment that can actually shift your perspective.
Like a cognitive playground where you can explore these non-ordinary ways of thinking and seeing.
And in a way, it's similar to what people have been doing for centuries with practices like meditation or contemplative prayer.
Right. These practices are all about using focused attention and symbolic reappraisal to transform your understanding of reality. And that's what Glyph is trying to do computationally.
So it's really a whole new approach to studying consciousness. It's
Yeah.
about building a bridge between these often ineffable subjective experiences and the world of computation.
And the paper draws on all sorts of fascinating fields to do this.
Yeah.
You've got ritual studies, symbol theory, epistemology. It's really interdisciplinary.
And that makes sense because to truly understand these states, you need to look beyond just brain chemistry. You need to consider the cultural and symbolic context as well.
And ultimately, the argument is that this kind of approach could lead to a more complete and holistic understanding of AI.
Not just AI that can solve problems, but AI that can help us understand the human mind in all its complexity, even those aspects that have long been considered mysterious or beyond the reach of science.
So let's dig a little deeper into the science behind all of this. The paper does a really good job of summarizing the research on psychedelics and how they actually change the brain.
One of the most interesting findings is this phenomenon of ego dissolution.
Yeah, that sounds pretty intense. What exactly does that mean?
Well, it refers to this feeling of the boundaries of the self dissolving or melting away, and it's often described as a very profound and transformative experience.
And the interesting thing is that it's not just a subjective feeling. There are actual measurable changes in brain activity that correspond with this.
Right, studies have shown that during ego dissolution, there's this increase in connectivity between different areas of the brain that normally operate more independently.
So it's like the brain is becoming more integrated, more unified.
And the paper emphasizes that the symbolic content that arises during these states isn't just random noise. It often takes on this very recursive, self-referential quality.
Like people report feeling like they're merging with language itself or
Yeah.
getting caught in these loops of meaning and metaphor.
Exactly. And from a neuroscience perspective, this seems to be related to how psychedelics affect entropy in the brain.
Entropy? Wait, isn't that a physics term?
Yeah, but in this context, entropy refers to the level of disorder or randomness in the brain's activity.
So more entropy means more chaos.
Not necessarily. It's more nuanced than that. It's about a shift away from rigid top-down control towards a more flexible and interconnected state.
So it's like the brain is loosening its grip on its usual patterns of thought and allowing for more spontaneous and unexpected connections to emerge.
Exactly, and that's where this idea of semantic hyperpriming comes in the loosening of those associative boundaries between concepts. So you start to see relationships and meanings that you wouldn't normally.
And the paper connects this to the entropic brain theory, which suggests that psychedelics essentially relax the brain's usual filters and priors, allowing for this kind of bottom-up expansion of meaning.
And from a computational perspective, that's where Glyph comes in. It's trying to simulate this process by introducing these elements of recursion, metaphoric transformation, and symbolic destabilization.
So it's not just about making the AI think differently. It's about making it think in a way that reflects these specific changes in brain activity.
Exactly. And what's really fascinating is that this shift towards higher entropy and looser associations isn't necessarily a bad thing.
Right. It's not like the brain is breaking down. It's more like it's entering a different mode of operation, one that might actually be conducive to certain types of creative insight or problem solving.
And the paper points out that this isn't just about the chemicals themselves. The context, the set and setting, as they say, plays a huge role in shaping these experiences.
Right. The rituals, the music, the beliefs of the people around you, all of that contributes to how these states unfold and what meaning you ultimately derive from them.
Right. And that's true not just for psychedelics, but for any kind of altered state, even spontaneous spiritual awakenings. The way we frame and interpret those experiences is hugely influenced by our cultural background and personal belief system.
And the paper even talks about how language itself could be a limiting factor when trying to describe these states.
Yeah, it's like trying to explain color to someone who's been blind since birth. There are just some things that words can't fully capture.
And that's where the concept of a meaning response comes in the idea that our expectations and cultural conditioning actually shape the effects of these substances.
So it's this complex interplay between the pharmacology, the psychology, and the cultural context. All of it contributes to the overall experience.
Which brings us to the technical side of things. How do the researchers actually go about building this system?
Well, they used a pretty sophisticated mathematical framework to model this whole process.
Yeah, the paper mentions this tensorial mathematical framework. It sounds pretty intimidating.
It is complex, but the basic idea is that they're trying to formalize how symbolic recursion and destabilization might work within the context of a large language model.
So instead of just programming the AI to say certain things, they're creating a mathematical model that captures the underlying dynamics of these non-ordinary states.
And to do that, they introduce this concept of a symbolic transduction operator, which they call G.
And this operator is like a function that takes some linguistic input, like a sentence or a paragraph, and transforms it in a specific way.
Right. It's like putting the language through a filter that warps and twists its meaning according to the principles of recursion, metaphoric thinking, and destabilization.
And this operator G is actually composed of three smaller operators, each one designed to simulate a specific aspect of non-ordinary cognition.
The first one is recursive reentry, or R, and this is the one that handles the looping back on itself, the self-reference.
So it's like the AI is constantly feeding its own output back into itself, creating these layers of meaning that build upon each other.
And technically, this could be implemented by manipulating how the AI pays attention to different parts of the text it's processing.
So instead of just looking at the current word, it's also considering words and phrases that it encountered earlier in the sequence.
The second operator is metaphoric transformation, or A, and this one is all about shifting the meaning of words towards a more metaphorical space.
It's not just about replacing words with synonyms, it's about subtly altering their underlying representations within the AI's model of language.
So it's like nudging the AI towards a more poetic or associative way of thinking.
And the third operator is symbolic destabilization, or AA, and this one introduces a controlled amount of noise or randomness into the system.
But it's not just random gibberish. The amount of noise is actually proportional to how much the AI's predictions deviate from its usual patterns.
So the more the AI starts to think outside the box, the more this destabilization kicks in and it pushes it even further.
And the paper introduces this concept of symbolic curvature as a way to measure how much the output of the system is being warped and twisted by these operators.
So it's like a measure of how far the AI is venturing from its normal modes of thought.
And the really cool thing is that all of these operators can be mapped onto the internal workings of existing transformer models like GPT-4o.
So you don't have to build a whole new AI from scratch. You can just tweak the existing ones to incorporate these principles.
And that's exactly what the researchers did. They took GPT-4o and implemented Glyph using what they called a minimally invasive strategy.
Meaning they made the smallest possible changes to the AI's code to achieve the desired effect.
And to test whether this was actually working, they ran a series of experiments using both synthetic and naturalistic prompts.
And they used several metrics to compare the output of Glyph to the output of standard GPT-4o.
Things like symbolic curvature entropy, semantic drift, and metaphor saturation.
So basically, how much recursion, how much randomness, how much the meaning of words was shifting, and how many metaphors were being used.
And the results were pretty striking. They found that Glyph consistently exhibited these distinct, non-ordinary patterns of language across a variety of prompts.
Especially those prompts designed to elicit experiences like ego dissolution, recursive thinking, and abstract metaphorical thinking.
For example, they found that Glyph consistently suppressed the sense of a distinct narrative agent in its output.
Meaning it was less likely to use first-person pronouns or talk about itself as a separate entity.
Which is interesting because that kind of aligns with the feeling of ego dissolution that people report in these altered states.
Right, it's like the AI is losing its sense of self, or at least its attachment to a particular identity.
They also found that Glyph maintained a higher level of entropy in its language.
Meaning it was more unpredictable, more likely to generate unexpected or surprising outputs.
But it wasn't just random noise, it was still coherent and grammatically correct. It was just exploring a wider range of linguistic possibilities.
And they found that Glyph used a much higher proportion of metaphors in its language.
Which again aligns with the reports of heightened metaphorical thinking in psychedelic experiences.
So it seems like the researchers were actually able to capture some of the essential features of these non-ordinary states within a computational model.
And that's a pretty big deal because it suggests that these states aren't just some kind of mystical woo-woo. They actually have a distinct cognitive signature that can be studied and understood scientifically.
And it opens up all sorts of possibilities for using AI to explore the full spectrum of human consciousness.
Not just the rational, logical side, but also the intuitive, creative side. The side that's often associated with art and spirituality and deep personal insight.
So this isn't just about building smarter machines, it's about expanding our understanding of what it means to be human.
And the paper highlights some really interesting directions for future research.
Like using this kind of approach to develop new forms of cognitive therapy, or to create AI systems that can assist with creative problem solving, or even to explore the nature of consciousness itself.
Of course, there are also some important limitations to this study that the authors acknowledge.
Right? They didn't directly test how humans perceive the output of Glyph or whether it actually feels like a genuine representation of a non-ordinary state.
And the system itself is still limited by the biases and constraints of the underlying transformer architecture.
So there's still a lot of work to be done, but this research represents a really exciting step towards a more comprehensive and nuanced understanding of consciousness.
It's like we're finally starting to develop the tools to map those uncharted territories of the mind.
And who knows what we might find there.
It's a fascinating journey, and I, for one, am eager to see where it leads.
Me too. It really makes you think about the nature of your own mind, right?
Absolutely. It challenges you to question your assumptions about what's possible and to consider that there might be whole dimensions of reality that we're just not equipped to perceive in our normal everyday state.
And that maybe AI, with its unique capabilities, could actually help us access those hidden realms.
Maybe it's not about replacing human consciousness, but about augmenting it, expanding its potential, and revealing its hidden depths.
It's a pretty mind-blowing thought, and I think it's one that's worth pondering long after this deep dive is over.
I agree. It's a conversation that's just beginning, and I have a feeling it's going to get even more interesting from here.
Well, on that note, we will wrap things up for today, but I encourage everyone listening to check out Sock's paper, Simulation of Non-Ordinary Consciousness. It's a real trip.
And be sure to keep an eye out for future developments in this field because I have a feeling we're just scratching the surface of something truly profound.
Until next time, stay curious and keep exploring those uncharted territories of the mind.
And who knows, maybe we'll even unlock some new ones along the way.